Question number 1. Oxidation number and valency of the carbon atom in CH2, Cl2 respectively. First of all, can you draw the structure CH2, Cl2? CH2, Cl2, C, H, H, Cl, Cl. Okay. For valency, in the carbon atom, this is the central atom. Carbon, what is the electronic configuration? 1s2, 2s2 and 2p2. At its final shell, there are 4 electrons, 2 plus 2, 4 electrons. All the outer electrons, all the 4 electrons are involved in bond making. Therefore, its valence is 4. Valence is 4. How to calculate the oxidation number of carbon? When consider the hydrogens, when it is not a metal hydrogen OH2, hydrogen normally takes +1 oxidation number. +1 oxidation number. +1 means +2. Chlorine is chlorine is an electronegative atom. Therefore, it takes -1 oxidation number. -1 means again -2. +2 plus -2 means 0. Therefore, carbon should take the oxidation number as 0. Okay, answer is number 3. Increase in sequence of boiling points of compounds. Okay, for both melting point and boiling point. We have to think about the intermolecular forces between molecules. Okay, or considering boiling point as well as the melting point, we have to consider about their intermolecular forces. Look at the compounds. What are the, for considering intermolecular forces, we have to consider what are the polar molecules and what are the non-polar molecules. Okay, take the 4 molecules: CH3, CH2, CH2, CH3. Okay. It is a non-polar molecule. Non-polar molecule. What are the other molecules? CH3, CH2, CO, CH3, CH3, CH2, 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 OH, CH3, CH2, CH2, CO, OH, COOH. Okay, you can see only this one is the polar molecule and those are the non-polar molecule and those are the polar molecules. Polar molecules. This molecule, actually, this is an alkane. Alkane here, ketone, alcohol, and carboxylic acid. Okay, carboxylic acid. Due to its non-polar nature, it has only London forces or van der Waals interactions. Only London or van der Waals interactions. These molecules also have London or van der Waals forces, but they have another strong intermolecular forces than London or van der Waals forces. Therefore, the intermolecular forces of these 3 compounds are higher than this one. Therefore, the minimum boiling point, the lowest boiling point has CH3, CH2, CH2, CH3. Lowest one. Okay, lowest melting point or boiling point. Next, compare 3 polar molecules. This is a ketone, alcohol and carboxylic acid. These polar molecules, all of the polar molecules, they have bipolar interactions. There is a specific bond bipolar. This is actually specific bipolar interaction type we call as hydrogen bonds. These hydrogen bonds are stronger than all of another bipolar interactions. Hydrogen bonds. Okay. Which molecules have hydrogen bonds? For making hydrogen bonds, there should be a hydrogen atom. This hydrogen atom should be bound with an electronegative atom. We are talking about 3 electronegative atoms, oxygen, nitrogen, and fluorine. There should be in the molecule, in the particular molecule, there should be HO bonds, OH N bonds, OHF bonds. Okay. You can see here no HO, OHN, HF bonds. Therefore, hydrogen bonds are absent here. But in here, you can see OH bonds. That means hydrogen bonds. Both of these molecules can make hydrogen bonds. Okay. You know hydrogen bonds are stronger than other all bipolar interactions. Therefore, the melting point or boiling point of ketone is lower than alcohols and carboxylic acids. Therefore, the next molecule is ketone. CH3, CH2, CO, CH3. Okay. There are only 4 carbons, same carbons. Between carboxylic acids and alcohol, normally, remember, acidicity or melting point, boiling points for same carbons. Okay, alcohols are low in acidity and melting or boiling points than carboxylic acid. Carboxylic acids are stronger ones. Okay, due to its what? You can see there is a OH bond and OH bond here also. Think about the adjacent carbon to the oxygen, adjacent carbon to the oxygen. Here, carbon has 2 hydrogens, Here, carbon has an oxygen atom. Due to the electronegativity of the oxygen atom, it takes delta minus charge and therefore carbon has to take delta plus charge. Okay, due to this plus charge, oxygen, actually the electrons of this bond are pulling to this carbon. Therefore, oxygen has an deficiency. Therefore, hydrogen can easily leave the oxygen atom and make H plus ions. But in here, carbon is attached with the 2 hydrogens. They are not electronegative atoms. Therefore, carbon is not pulling electrons from the oxygen. Therefore, for removing this hydrogen as H plus, this carbon is not helping like this. Therefore, the acidicity or melting point, boiling point. Actually, here we are talking about the polarity of the OH bond. Polarity actually. In the acidicity, again, we have to think about this polarity. However, the melting or boiling points of carboxylic acids are higher than the alcohol. The next molecule is CH3, CH2, CH2, CH2OH and CH3, CH2, CH2, COOH. Answer is number what? You can select the answer. Answer is number 1. Okay, answer is number 1. An element shows only 2 and 4 valences. We have to find the correct electronic configuration. Okay, valence is only 2 and 4. What is the correct electronic configuration for observing by observing the electronic configuration, you can easily catch the answer. Only valence is only 2 and 4. So can you identify what are the elements? 3D4, 4s2 means chromium. Okay, 2s2, 2p4 means oxygen. 2s2, 2p2 means carbon. 3s2, 3s2, 2p4 means sulfur. 3s2, 3p1 means aluminium. 4s2, 3p1 means aluminium. Carbon has only 2 and 4 as its balances. Therefore, answer should be number 2. Compound with the highest bipolar moment. For considering the bipolar moments, we have to think about their asymmetrical distribution. Okay, asymmetrical distribution of draw the structures: carbon, chlorine, hydrogen, and hydrogen. You can see 2 electronegative atoms are in one direction. Hydrogen tends to give electrons. We can see hydrogen is an electropositive atom. You can see 2 electronegative atoms are in one side, and another side 2 electropositive atoms are there. Hydrogen push electrons along this bond. Therefore, overall goes to this direction, and chlorine, 2 chlorines are pulling electrons into this one. Therefore, the overall bipolar moment goes to this direction. The second one, carbon, hydrogen, chlorine, hydrogen. You can see even there are 2 electronegative atoms are there. These two electronegative atoms, electrons are pulling in opposite directions. Same force for opposite direction. Here also same force into this direction and same force into this direction, but they are opposite. Okay, in opposite direction. Therefore, overall is 0. Third molecule, carbon, chlorine. Again, you can see overall bipolar moment is 0 because same atoms, 4 same atoms, chlorine, are pulling electrons into 4 opposite directions. Therefore, overall bipolar moment is 0. And chlorine, bromine. Here, chlorine is more electronegative than bromine. 2 electronegative atoms are pulling electrons into this direction, and bromine also an electronegative. Therefore, it pulls electrons. They are pulling electrons into this direction. Overall goes to this one. Here, overall goes to this one. You can see we have to subtract the force by chlorine, bromine by chlorine. Now, therefore, here also a net bipolar moment is there, but not much as this one. Okay, up to now, the highest bipolar moment is there. Carbon, bromine, chlorine, opposite direction, same force, overall 0. Answer is number 1. Mass of K2SO4 dot Cr2SO4 thrice SO4 thrice 24 H2O. Mass, we have to find the mass. Okay, what is the amount of mass of this compound for making Cr3 plus solution. Concentration is 10.4 ppm and volume 1.0 cubic decimeter, and molar mass is there. Molar mass of the compound is 894 grams per mole. Okay. First of all, you have to convert this concentration to non-concentration. Okay. Then, and before that, imagine the whole reactions are occurring at 1 cubic decimeter volume. Then we can easily find the answer if you considering the whole procedure, the whole reaction is occurring at 1 cubic decimeter volume. Okay. Okay. How to convert ppm into mgdm minus 3. 1 ppm is equal to 1 mgdm minus 3. Therefore, 10.4 is equal to 10.4 ppm is equal to 10.4 mgdm minus 3. Okay, we are dealing with grams. Therefore, we have to convert this mg mass into gram. So we can ignore the concentration because we are thinking about 1 cubic decimeter volume. So we have to make a 10.4 milligram chromium 3 plus sample. Okay, 10.4. We can convert 10.4 milligram into gram. Therefore, we have to multiply this one into 10 to the power minus 3. Here, the mass of chromium, and then we can calculate the number of moles by dividing this mass by the molar mass of chromium. It is 52 gram per mole. Okay, 52 gram per mole. Then we have calculated the number of moles of Cr3 plus. Then we can calculate the number of moles of the whole compound. You can see in 1 mole of compound, there are 2 moles of chromium is there. For making 1 chromium mole, half of the moles of the compound is required. Enough. Okay, therefore, we can multiply the number of chromium moles by half. Okay, so now we have calculated the number of moles of whole compound. Then we can convert it into the mass of the whole compound. You know, n is equal to simple m over capital M. Therefore, for considering the m, that means the mass, we can multiply moles into molar mass. Therefore, molar mass is given. Okay, this is the answer. How we can calculate it? 10.4. 52 into 2 means 104. Okay, 104. Then here 0.1. 0.1, 10 to the power minus 3 means 10 to the power minus 4. 10 to the power minus 4 into 894 grams. Okay, then we can calculate it as 0.0894 grams. No any answer like that. but we can convert it into milligrams. How we can calculate the gram into milligrams? By multiplying 10 to the power 3. Therefore, 89.4 milligrams is enough. 89.4 milligrams of the whole compound is enough for making 10.4 ppm concentrated Cr3 plus solution. Okay. 8. The element should be presented in P block. Here, you have to clearly read the question. Now, I am talking with the discussion. The element in the question number 8, the element should be presented in D block. The element should be presented in D block, and but it is not esoteric element. Okay, esoteric element. Can you remember the 10 elements of D block? Scandium, titanium, vanadium, chromium, manganese, cobalt, nickel, copper, zinc. Okay, those are the D block elements. All are metals, but not all are esoteric. Okay, zinc is not esoteric. Other all are esoteric metals. What is the point for considering as esoteric metals? Definitely, all should be D elements, D block elements. Okay, therefore, if they are magnesium, beryllium like metals, we can easily ignore it. Okay, for considering as esoteric elements, the element should be in the D block. And the second condition is the particular element, the particular esoteric element should have incompletely filled the sub-energy level. Incompletely filled the sub-energy levels. Okay. In the elemental stage or at the stage of the most stable ion. Okay. This scandium, you can see the electronic configuration is 4s2 3p1 here. Incomplete D block is there. Other all elements have incomplete D block, incompletely filled the sub-energy level in the elemental stage of the most stable ion, but in zinc, at this elemental stage, the electronic configuration is 3d10OS2, and the most stable cation is zinc 2 plus, and the most stable ion or in the zinc 2 plus ion, its electronic configuration is 3d10. Therefore, zinc is not an esoteric element. Answer is zinc. Okay. Number 9. In number 9, you have to choose the pair with different shapes. Okay, can you draw the structure easily? CO2 like that. EeCl2 like that. Okay, can you imagine the shape? Here both have linear shape. Both have linear shape. PO4 3 minus and S2O3 2 minus. PO4 3 minus is like that. Tetrahedral. S2O3 like that. Tetrahedral. Both are tetrahedral. NCl3 and BCl3. NCl3 has pyramidal shape, but BCl3 has trigonal planar shape. Okay, BCl3. This pair has two different shapes, pyramidal and trigonal. And think about others. NO3 minus SO3, SO3 trigonal planar, NO3, NO3 minus NO3 minus again trigonal planar. Answer is NCl3 and BCl3. Can you draw the Lewis structure? Can you fill the remaining electrons here? Like that. Here 7 electrons should be there around the chlorine. Oxygen 6 electrons. Oxygen 6 electrons and additional electrons due to the negative charge. Here again, like that. Okay. Chlorine, 7 electrons, 7. And NO3 minus, let's look like this. Oxygen. Answer is NCl3 and BCl3. IUPAC name. You have to find the IUPAC name. In the advanced level syllabus, we are talking about two IUPAC names, inorganic for inorganic compounds and organic compounds. Here, IUPAC name for organic compound, CH3, CHI, C, triple bond C, CH2OH. 1, 2, 3, 4, 5. Okay. First of all, you have to select the main functional group. You have to identify the main functional group. Here you can see this is the main functional group. It is an alcohol. Therefore, the name should be ended with the term ol. There are another functional groups, but much not strong as the main functional groups. Therefore, iodo, and then you can select the main functional, the main carbon chain, very easy. Okay, then you can number in the chain. You have to give the minimum number to the carbon which has the main functional group. Therefore, 1, 2, 3, 4, and 5. How we can name it? First of all, there are two name sets. Okay, in the name set 1, it includes the names of other functional groups than the main functional groups. There are only one other functional group. Therefore, the name is O-iodo. O-iodo. There is a triple bond on the second carbon. Therefore, 4-iodo. 2 pent ine, 1 ol, or 4-iodo, pent, 2 ine, ol. Okay. This ine is due to the triple bond, but the last letter is removed because there are another names at the end. Answer is this one: 4-iodo, 2 pentine, 1 ol, 4-iodo pent, 2 ine, 1 ol. 11. You have to select the element pair which produce solid dioxide in the room temperature. We have to consider about dioxides. Okay, 2 oxides like that. Okay, O2, not oxides. Oxide means O2 for considering as dioxides. Okay, in the room temperature, here all metals produce solid oxides, okay, but not dioxides. All metals produce solid oxides. All metals produce solid oxides at the room temperature, but we have to think about dioxide. O2 minus plus O2 minus. Okay, the oxidation number of one oxide is -2. Therefore, 2 oxide means -4. The particular element should can the element particular metal can have to make +4 oxidation number. Okay. First pair manganese and copper. Manganese MnO2 +4 okay, but copper dioxide no. The highest oxidation number of copper is copper 2 plus. Therefore, copper cannot make dioxides. Manganese sulfur MnO2 okay. SO2 okay, but SO2 is not a solid, it is a gas. MnO2 is solid. Copper and nickel, CuO2 incorrect. The highest oxidation number of copper is copper 2 plus, nickel O2 okay. Titanium dioxide and silicon dioxide both are solids. Answer is this one. SO2 and NO2 okay, but both are not solids, they are gases. 12. Prussian blue precipitate. You have to think about the Prussian blue precipitate, not dark blue precipitates, light blue precipitates. You have to think about the Prussian blue precipitate. This blue precipitates, when we are considering these blue precipitates with particular complex K3FeCN6, Fe2 plus and Fe3 plus produce blue color precipitates with this compound, but only Fe3 plus produce Prussian blue precipitate, but Fe2 plus produces dark blue. It is not Prussian blue. Fe2 plus makes dark blue precipitate. Okay. Fe2 plus aqueous plus K3 FeCN6. What is the complex? What is the dark blue precipitate? KFeCN6 plus 2K plus. This is the dark blue precipitate. Okay, dark blue precipitate. Fe3 plus 4Fe3 plus equals 4Fe3 plus K3. Here, this equation, those equations we are writing in inorganic chemistry. Therefore, physical states are not essential. K3 FeCN6 into Fe4 FeCN6 thrice solid plus 4K plus. This is the Prussian blue precipitate. Answer Fe3 plus. The answer should be reacted with in the question number 13, the answer should be reacted with Grignard region as well as the product should be a Grignard region. Answer is number 5. Terminal alkynes behave as the procedure. Terminal alkynes like CH3CH reacts with Grignard. All answers are reacting with Grignard, but the product is not a Grignard. Okay. Answer number 5. In the Grignard region, RNGX. It looks like RNGX. The R may CH3, CH3, CH2, C2, H5, branched one, any alkyl group. Okay, normally the Grignard region is polarized as NGX delta plus and R minus. Here in terminal endpoints you can see there is also a polarization, like due to the alkaline, due to the acidic nature of this terminal hydrogen, it polarized as delta H plus and delta minus. Okay, this delta H plus and this delta minus are combined and produce an alkane, and this delta minus group and delta plus group are combined and produce again the Grignard region CH3C triple bond NGX. This is the product of this reaction, and again it is a Grignard region. What are the equations? C2H5OH, sorry, C6H5OH, this is the phenol, plus RMGX, C6H5NGX and C2H5OMGX and RH alkane, and NH3 plus RMGX. Like in phenol, the hydrogen combined with the this R group, like that. One of the hydrogen of ammonia is combined with this R and produce RH. The remaining NH2 minus and MgX produce the product NH2 MgX. CH3 CO2H carboxylic acid and RMgX. That means CH3COOH. The terminal hydrogen and MgX are combining to produce the terminal hydrogen goes with the R group, produce RH, and the remaining negative part and MgX combining RMgX plus OCH RMgX CH3CO2 RMgX plus RH CH3OH plus RMgX CH3O MgX plus RH, and our answer CH3C triple bond CH plus RMgX CH3C triple bond C MgX plus RH. This is the answer. 14. 3.0 milligram sample of an evaporative liquid is evaporated at 127 degrees Celsius. At 1 into 10 to the power 5 Pascal pressure, the volume of vapor phase is 16.65 cubic centimeter. If the vapor behaves as an ideal gas, the liquid may. There is an evaporative liquid.